Class, can you see the screen? Kyle.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So
So would it be
let's
possible
start.
to zoom in a bit, sir? Like the
Yeah,
letters are really
I'll
small.
do it from scratch. Yeah.
No, sir, I'm talking about, sir, if you could zoom in a bit, sir. The letters are kind of small, sir. If you could increase the
I
font
couldn't.
size or
I
something.
mean, your voice is getting muffled. So can you just
Sir,
type?
Sir, could
sir,
you
if you
zoom
could
in a
in,
bit? The
Okay,
letters are very
zoom in.
small.
Oh, that I think might
sir,
become.
if you could increase the small font size, sir.
Yeah, I'll try, but that itself is a difficult issue. I'm not very sure how to zoom this text.
Sir,
So it's okay, sir. You can continue, sir.
if you press the control button and scroll the mouse in upward direction, I think it will work.
You press the control button, then what? Do what?
Sir, scroll the mouse in upward direction.
Yeah, but nothing is happening.
Sir, you could write in the notepad and then copy the code.
Yeah, that I can do. Yep. So you can view this.
Yes, sir. Right.
Okay. So see, when you write a program in assembly language, then it has to start with a directive, which is called org. Okay. It says that when you burn the program on the prompt, it will start from location all zero hex. Okay, so without this, the program will never work. Clear? Without this, the assembler cannot generate the executable code because it does not know from where it will write the code. So if you write a program without this, then definitely you'll lose some marks. And similarly, when you end the program, you have to write an end. So these two are not assembly language instruction. They are essentially assembler directive. The assembler understands that when it will generate the code, then the code will be mapped from all zero hex onwards, and end means that's the end of file. Okay, So that's the end of code. Now, why you have to write all zero hex? Because the chip is designed like that. Whenever you go power on reset, give it power on reset, it will initiate reading code from all zero hex. A microprocessor or a microcontroller is a device which, when powered on, will fetch and execute code. And by design, it will start fetching the code from all zero hex onwards. Okay, so you cannot bypass this. So you have to write this org all zero hex. Now suppose your task is you want to write the code from say 0040 hex. Then all you have to do is after all 000 hex you have to write 0040 hex. Am I clear? That means the first instruction it gets is basically a jump instruction which will take it to 0040 hex, and then you have to write the corresponding code. But if you miss the first two lines and if you start with org 0040 hex, then it's a difficult issue. Difficult issue in the sense that the processor will make an entry at 0000 hex, and at that particular location it will not find any valid code, any valid instruction. So the system will simply hang. It will stay in that particular point. It will not fetch and execute. Okay, so that means you have to start from all zero hex, and if you intend to put your code from 0040 hex or maybe any arbitrary location, you have to write an ljump and then go to that location through org 0040 hex or whatever be that location, and then start writing the code from there. So am I clear? So that these two org and end, they are essentially assembler directives. They will direct the assembler to put the code at that particular location. Clear? So any program written without these two lines is basically an invalid program. The assembler will not allow the corresponding the generation of this compilation of the code and generation of the executable code. Clear?
Hello,
Sir,
sir.
in this is
Please speak a bit loud because I have problem hearing you. Or you can write the text. You can text it. Okay.
sir, is the instruction at 0000 hex equals to ljump 0040?
Once again, your voice is getting muffled. Can you write it? You can text it. Please text it. Yes. Yes, Shuddha. At all zero hex, I'm writing an ljump 0040 hex. So it means that the program will get an entry at all zero hex, and there it encounters an instruction which is ljump 0040 hex. Is necessary since we already. Yes, 0040 hex is essential because the assembler does not know. You see, the assembler does not know where from it will start. Ljump 0040 hex will take the microcontroller to that location. But prior to that, the assembler must write the corresponding code at 0040 hex. Am I clear? So to write this org statement so that the next statement essentially goes to 0040 hex. Okay. Right. So if you once again go to this, sorry. So now let's get rid of this. We will start from this. Okay. So say you want to run a clock. You generate a clock at P1.0, right? And there is no hard and fast constraint regarding the frequency of the time period of the clock. You need to have a clock. Okay. So the simplest way to write a clock is something like this. You put a label. So say, call it L0. At L0, you simply write complement P1.0. Means the 0th bit of port P1 is being complemented. The next line you write sjump P1.0. It says that after complementing the pin, the next instruction is you once again jump back to sorry, not L1 to L0. The sequence is L0 CPL P1.0 which stay at all 0 hex. So the program makes an entry at all 0 hex. It executes this. That means the port pin is being complemented. If it's a 1, it will become a 0. And then it comes to the next line, which says that you go back to the line L0. So it goes back, it once again complements it. So if previously it was 0, it will become a 1. It once again comes to this line, it jumps back to L0. So in every step, the port pin P1.0 is being complemented. Okay, so that will generate a clock. Now, what is the period of each the time taken to complement a bit? So that is equal to the execution time of this CPL statement and that sjump statement. Clear? So with that period, so first it will say toggle from 1 to 0 and then 0 to 1. So this time period into 2 is the clock time period, and the reciprocal of that is the clock frequency. Am I clear? So let's do one thing. Let's copy this code and put it into Kyle. Okay. So this particular editor, that means editor, this is integrated with this MuVision program. It basically goes for a text highlighting, right? So if you see all the instructions and the directives, they are colored in blue. Okay. So if there's some typing error, or maybe if you don't remember a particular, not enter a code correctly, suppose in place of sjump, so you make a typing error, you make it sjnp. So since sjnp is not a valid instruction, automatically the color changes. It becomes black. Okay. So this is very useful when you practice. Okay. So this is the timer program, very simple timer program. So you can compile it. So compile means you can build it, right? Okay. So it's being compiled with 0 errors and 0 warning. So that means that's a correct compilation. But you have to generate the corresponding hex code so that you can run it. So for that, go to target, go to the options for target. In the output section, take this, create the hex file. Okay, so once again, if you it, you'll find that some hex file is being created. This creating hex file from this, the file is being created. So until unless the hex file is equivalent to the exe file, this is the program, any C program or Python program that you built. Okay, so it means that now you can debug this program in the debug mode. Is it essential for you to learn debug? Class?
We don't know, sir.
Huh?
We don't know whether it's essential for us to learn debugging or not for the exams, to be specific.
How long will it run for? Okay, so so Shuddha is having two queries. First is how to generate the frequency information, and second is how will it run for. Okay, so for that you have to go to the debug mode for generating frequency. So I'll take the second question first. So you see it will run. It's while one loop. Okay, so that's an infinite loop. So as long as the power is switched on, it will run. Right. So when you switch off power to the board, the program will stop. That's it. So it will run an infinite loop because there is no condition where the loop will be broken. Clear. Now I'll just take this example to find the frequency. Okay. The rest you can do it on your own. So you go to the debug mode. Go to the debug mode. Right. So there you can step through the program. Right. So when you step through the program, you first come to this line. Okay. So you start the program. You come to this line. That L0 is set to P1.0, right? So you see only one state is being taken, and the corresponding time in seconds is this. Okay. So you come over here and run this program one by one, step by step, right? You find that the total time is changing. Okay. So here the trick is you simply come to here, this particular line. Okay. And right, you can plug in a analyzer window, right? So as you go through the program, you will find that the clock is being generated. Okay. So you can zoom out. Sorry, you can zoom in, and using the cursor, you can find out what is the time between. So here it's say 3 microsecond, and here it's, I think it will be some 9 microsecond. No, 3 plus 3. Yeah, it's 9 microsecond. So you see complement P1.0 is a one machine cycle instruction. You go to the instruction cycles summary, instruction set summary, you'll find that. And sjump will take 2 machine cycles for its execution. Now, one machine cycle is equal to 1 microsecond because it's working with a 12 megahertz clock. That's how it's being programmed. So three machine cycle instruction means the first one complement is a 1 machine cycle instruction. The second one is sjump L0 is a 2 machine cycle instruction. So taken together, each complement and sjump will take 3 microseconds. Now, for a particular bit toggle from 1.0 and then back to 1, you require 2 such loops. So one loop, that means it starts with a 1, then becomes a 0, then it becomes 1 second, becomes a 1. So this time is 3 microsecond plus 3 microsecond, that's 6 microsecond. So the period of this clock is 6 microsecond. So 1 microsecond is 1 megahertz, is 1/6 of a megahertz. So that's the frequency. Am I clear? Okay.
স্যার মেশিন সাইকেলের ব্যাপারটা যদি আর একবার বলেন।
মেশিন সাইকেলের ব্যাপারটা বাবু বুঝতে গেলে একটু তোমার পড়াশোনা করতে হবে, হ্যাঁ? যে এই প্রত্যেকটা ইনস্ট্রাকশন এক্সিকিউট করতে একটা টাইম লাগে, রাইট? So in the instruction set summary or in the slides that is given to you, right, you check what is the time taken by each and every instruction, right? So it's a clocked machine. It's a clocked digital circuitry. So the time taken to fetch the instruction from program memory, that's with the 4K into the PROM, and execute the same, it takes some amount of time, which is an integral multiple of the system clock. Right?
না স্যার, ওটা থেকে এখানে কি করে পিরিয়ডটা এলো ওটা যদি আরেকবার বলেন।
না, কি আরেকবার জিজ্ঞেস করো, কি প্রশ্ন?
স্যার ওটা থেকে এখানে টাইম পিরিয়ডটা কি করে এলো ওটা যদি আরেকবার বলেন।
আচ্ছা, তুমি কোডটা চলে যাও। কোডটা কি হচ্ছে, তুমি প্রথমে এখানে এলে, এসে প্রথমে এই লাইনটা এক্সিকিউট করবে, তারপর এই লাইনটা এক্সিকিউট করবে, করে আবার এই লাইনটায় চলে যাবে। তাহলে এই লাইনটা এক্সিকিউট করে মানে কি, ধরো 0 ছিল 1 হয়ে গেল, এখন কতক্ষণ পরে হলো না, that is equal to the execution time of this particular instruction. So that in this particular case is 1 microsecond. So if you look at the instruction set summary, you will find that all such complements, they take 1 machine cycle for its execution. Now 1 machine cycle is equal to 1/12 of the crystal frequency. This machine works with a crystal frequency of 12 megahertz. So 1/12 of that is 1 megahertz. The 1 megahertz corresponding period is 1 microsecond. Clear? The next instruction executes sjump L0. So sjump L0 will take 2 machine cycles. So execution of these two will taken together will take 3 microseconds. So it becomes 1 and it waits for, it jumps to L0 1 second, right? So that will take 3 microseconds. After 3 microseconds, what will happen? It will 1 second complement, because the instruction says you complement the port pin. So that 1 second, the second loop, it will remain 0 for 3 microseconds, and then 1 second it comes back to complement, it makes it to 1. So that means each such cycle will take 3 microseconds. A generation of one complete clock means 1 on time and 1 off time. That means for half the period it will remain 1 port pin, the other half it will remain 0. So the total time is 3 microseconds plus 3 microseconds, that's 6 microseconds. Clear?
Okay, sir. Okay.
So if you see, the simple thing is, if you put some other instruction over here, say so you simply write move A comma B. Move A comma B has nothing to do with this clock generation. Clear? But it's an instruction. Instruction means it will take some time for its execution. Am I clear? So let's check what really happens. We once again go back to the main mode. I compile it, recompile it. Okay. And once again I go back to the debug mode. Clear? Okay. So now if I run it, you see the period has increased. Why? Because if you once again check, this is 4 microsecond, this is 8 microsecond. So that means move A comma B is taking 1 microsecond, that means 1 machine cycle for its execution. Clear? So that is being added to half the period of the clock. So previously, when this line was not there, the period was 6 microsecond. Now it's 4 plus 4, 8 microsecond. Okay. Am I clear?
Yes, sir.
Yes, sir.
Okay. So what next?
So the questions that came in the CT, sir, if you could do them, sir.
What was the question? To generate a 20% or 25%
That
duty
was
cycle.
the second question, sir. Please do the first question first, sir. Then it will be easier for us.
First was a basic question.
Sorry, nahi, bhai.
Joydeep, can you remember the question? Is it the integral
Data, I have it in front of me, sir.
Average, sir.
average? Okay.
Yes, sir.
So suppose, to start with, you write two data. So you write move into R0, a data which is, say, hash, say 70 hex, and say move, say R1, a data which is hash, say 7f, or maybe say it's 70 hex. Let's start with the simple example. So obviously the average will be 70 hex. Clear? So So whenever you add something, right? So what are the instructions? Instruction set summary. Let's open that once again. Okay. I close this one. Or maybe I minimize this one. Or should I write it over here?
You can write it here only, sir.
So what value?
Huh? Okay,
You
so
can
let's
write
write
it
it
here,
over
sir.
here. Yeah, let's write it over here. So I move the first data into R0. So the data is, say, 70 hex. I move the second data into R0, R1. So that data, say, is once again 70 hex. Right. So the first thing is I have to add these two data. Clear? Now when I add to this two data, right? So I have to, not really remember, but we have to go to the instruction set summary to find out what are the possible options for adding data. Clear? So let's go to that. So I can add.
इंस्ट्रक्शन सेट का एग्जाम में पाया जाएगा ना
Huh?
इंस्ट्रक्शन
Hello?
सेट का एग्जाम में पाया जाएगा ना
হ্যাঁ, এটা থাকবে এক্সামে, মানে পার্ট অফ দ্য কোয়েশ্চেন পেপার আমি তো লিখে দিলাম। পার্ট অফ দ্য কোয়েশ্চেন পেপার আমি এই 27 তারিখে পরীক্ষা, এই সোমবার, তোমাদের বোধহয় 21 তারিখ পরীক্ষা না?
হ্যাঁ স্যার,
হ্যাঁ স্যার
সোমবার
মিনিট সিটি আছে।
তাহলে 21 এর আগে আমি আজকে বা কালকে আমি তোমাদের পাঠিয়ে দেবো এটা, তোমরা প্রত্যেকে ছেপে নিয়ে চলে এসো, ঠিক আছে? এক পাতার হবে,
ওকে
আমি কম্প্রেস করে এক পাতা করে দেবো, ছেপে নিয়ে চলে আসো। দেখো ফার্স্ট ইনস্ট্রাকশন আমি ইউজ করতে পারবো অ্যাড a, rn, ঠিক আছে? তার মানে আমাকে কি করতে হবে দেখো, এখন obviously after every power on reset the content of accumulator is cleared, so that's the advantage of working with 8051 or any such improved microcontroller, right? So জয়েন করার চেষ্টা করছে, সকাল সকাল এসে যাচ্ছে সব, ঠিক আছে? So what we have to do is, so I will add with a first R0. Obviously it will be R0 itself. Then I'll once again add with a the content of R1. Okay. So what will happen is this particular addition may end up with a carry, because the content of the accumulator can never exceed 255. Suppose if the two numbers are 150 and 150, then obviously if you add them up, it will become 300. So that means you have to take care of the carry bit. Clear? So you have to take care of the carry bit. So a simple right shift will not help. The simple right shift will work only in cases where the sum is less than 255. Am I clear? So why is a right
Yes,
shift
sir.
important? Because when you right shift a digital data or a binary data, it gets divided by 2. So it will always have the integer average. Clear? So let's, if I once again go to the instruction set summary, I'll check that what are the shift operations. I think there will be some.
So
So you see,
instead of right shift, okay.
there are two options. One is rotate right, and the second is rotate accumulator right through carry. Okay, so rotate accumulator right through carry is a 9-bit instruction. Okay, so what it will do, it will shift the carry into the MSB of the accumulator, and the LSB of the accumulator will be shifted to the carry bit. So here, so if you go to RRC, you search RRC, go to next. So this is RRC. So it says that the 8 bits of accumulator and the carry flag are together rotated 1 bit to the right. So bit 0 moves into the carry flag. The original value of the carry flag moves into the bit 7. No other flags are affected. So this is basically the instruction that you should use to divide something by 2 when there's a possibility of a carry. Then what will happen? The carry bit will flow back into the 7th bit of the accumulator, and the 0th bit of the accumulator will flow back into the carry. So this next operation is not important. What is important is the bit, the overflow bit should come back. That means that is taken into cognizance when I'm dividing the thing by 0. Okay, so let's check it in the program. So I'll
So
simply
instead
write
of doing this, why can't we use the div operation, sir?
Huh?
Sir, instead of doing this, sir, why can't we use the div operation, sir?
Yeah,
Div
you can
by,
always use, yeah. So div operator means you have to write move into B register hash 0 to hex. Am I correct? And then I have to write div AB. Here. So what will happen?
yes, sir.
The quotient will go into either A or B, that you have to check, and the integer remainder will go to the other register. So let's copy this program into Kyle and check what happens.
Sir, but in this one we are not considering the carry bit, right?
This one?
This one we are not considering what is happening with the carry bit. We are just considering that
Correct.
the
Correct. No,
accumulator is inside.
let's see what Sudhashatha has said.
Yes,
Let's
sir,
see how it works. And is there the chance that the system will fail? We'll check everything. Clear? So you
yes,
see
sir.
76 and 70x means the average will be 70x. Let's see whether it works. Okay. So you save it, you compile it. Just a minute.
এবির মাঝে কমা হবে না?
হ্যাঁ দেখছি, জাস্ট 5 মিনিট সময় হবে। গুরু হ্যাঁ সরি, একটা টেলিফোন কল আসলে। কোথায় কমা হবে বলছো? হ্যালো,
স্যার ডিআইপি এবির মাঝে।
দেখে নিচ্ছি, দেখে নাও ইনস্ট্রাকশন সেট সামারি থেকে দেখে নাও। অ্যাড হয়েছে এখানে, সাব হয়েছে, তারপরে মাল আর ডিভ থাকবে, ইনক্রিমেন্ট আছে, ডিক্রিমেন্ট আছে, ঠিক আছে? কোনো কিছু থাকবে না, জাস্ট ডিভ এবি লিখতে হবে, ঠিক আছে? ঠিক আছে, আমি বিল্ড করলাম। ঠিক আছে, সো 0 এর 0 ওয়ার্নিং, তার মানে এভরিথিং ইজ পাক্কা। আমি এবার ডিবাগে চলে গেলাম। গিয়ে আমি স্টেপ বাই স্টেপ এগোচ্ছি, একটা করে স্টেপ করে। হ্যাঁ, দেখো এইখানে কিন্তু রেজিস্টার কোনো দেওয়া আছে। সো প্রথমে আমি কি করছি, আমি R0 তে 70x এলো, তুমি দেখো ব্লুতে এসছে, আর মানে 70x এলো। তারপরে দেখো এ কিন্তু 0 হয়ে বসে আছে, কারণ আফটার পাওয়ার অন রিসেট অল রেজিস্টার্স আর ক্লিয়ার। তাহলে এ তে প্রথমবার R0 কে অ্যাড করলাম, 70x এলো। তারপর যখন অ্যাড করবো E0x হবে, কারণ 7 + 11 is 14. So this number fortunately is less than 255. Clear? So there is no issue, just add করলেই হয়ে গেল। এইবারে আমরা কি করছি, আমরা এটাকে এ তে এই জিনিসটা রয়েছে, এবার আমরা বি তে দেখো 2 করলাম, করে আমি এ কে 2 দিয়ে ভাগ করলাম, দেখো এতে 70x হয়ে গেল, দ্যাটস দ্য অ্যাভারেজ। ওকে, so this method which Shuddha Shattu has pointed out will work fine as long as the number is less than 255. So let's make a small change. আমি দুটোকেই 80x করে দিচ্ছি। দেখো 80x + 80x হবে 8 8 16, 16 means it's 100 hex হয়ে যাচ্ছে, right? So that is 256, not 255. So that means there will be carry. So once again, if you divide, the average will be 80. Clear? But let's see whether it works now. This algorithm which Shuddha Shattu has suggested. আমি আবার একই কাজ করছি, আমি স্টেপ করে করে যাচ্ছি। দেখো 80 এলো, 80 এলো, অ্যাড করলাম 80 এলো। ঠিক আছে, সেকেন্ড টাইম অ্যাড করার সময় আমি PSW প্রোগ্রাম স্টোরেজ ওয়ার্ডটাকে এক্সপ্যান্ড করছি। দেখো এখনো কিন্তু ক্যারি 0, কিন্তু এবার যখন 80 এর সঙ্গে আমি 80 কে আবার অ্যাড করব, হ্যাঁ, তখন কি হবে, ক্যারি বিট ইজ সেট। তার মানে সিস্টেমের ভ্যালু অফ এ ইজ নাও 0 0, right? But the carry bit is 1. That means the added number is essentially a 9-bit number whose value is 256 and not 255. So now if you divide by 2, then the value will be 0 only. So average of 80x and 80x as decided by your algorithm is 0x. That is incorrect. So this algorithm of division the number by 2 will work only if the sum is less than or equal to 255. Otherwise it will not work. So what you have to do now is basically you have to I think it's RRC or simply RRC. Is it essential to write an A? Let's check. This is add, no. It's the next page. Increment. Yeah, I have to write an A. So it's rotate accumulator right through carry. Okay. It's RRC A. I save it. So go to debug mode. So if you run through the program, now once again, after adding, so it becomes 0 0, content of A becomes 0 0, but the carry bit is now. So now if you rotate right through carry, then what will happen, you see, this carry bit of 1 will enter the MSB of A. So most significant of A becomes 1, so the number becomes 80x immediately. Okay, so that's end of the program. So end of the program, the content of A is 80 hex. Shudha, have you understood what really happened?
Yes, sir. Yes, sir.
Okay. So for the rest of the class, I mean, for those who are still guessing what really happened, so you see this is a 9-bit and this one is carry bit and the rest is accumulator. This is accumulator, right? So after adding 80x and 80x, the result was a 1 over here and 0 over here. Zero, 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 zero. So that is what already happened. So after summing up 80x with 80x, it becomes 90x, right? Now rotate right means the carry bit will enter here and this 0 will flow back and enter into this carry. So after rotate right through carry, this becomes a 1 because this flows into this and this flows out and goes into carry. So carry becomes a 0. See what is the result? That is 80x. So it becomes a Pakka division by 2. Okay. So if the idea, if the I mean sum is something like this, which might come in your semester exam, so you have 4 numbers, right? You sum them up and find out the average. Then what do? You simply right shift twice, but you use this rotate right through carry, but very carefully. So take it as an exercise. So you have 4 integers, you sum them up and find out the average, integer average. So there you have to make a creative misuse of this algorithm, right? You think it
Sir.
out and do it on your own.
Hello, sir.
হ্যাঁ বলো।
স্যার একবার রোটেট রাইট টু ক্যারি করলে পরের বার মনে হয় শুধু রোটেট রাইট করতে হবে, কারণ পিছনের বিটটা তো সামনে চলে আসবে, সো সেটা জানি না যে কি 0 কি 1।
না কেয়ারফুলি ভাবো, প্রত্যেকবারই রোটেট রাইট টু ক্যারি করতে হবে, বাট ইউ হ্যাভ টু ডু সাম ট্রিক উইথ দ্য ক্যারি বিট। সো ইউ ফাইন্ড ইট আউট হোয়াট ইজ ইট, টেক ডিফারেন্ট নাম্বারস এন্ড ফাইন্ড ইট আউট।
ইয়েস স্যার, ইয়েস ওকে স্যার।
ঠিক আছে, কারণ এটা ছাড়া কিন্তু শেখা যায় না। সব স্যার করে দেবে তাহলে কি করে হবে?
ইয়েস স্যার, ইয়েস স্যার।
ইটস ভেরি আনফরচুনেট, তোমাদের পুরো ক্লাসের মধ্যে 90% ক্লাস কিন্তু কোডিং করবে, কিন্তু বেসিক টেনেটস অফ কোডিং কিন্তু শিখলে না। এনিওয়ে দ্যাটস নট মাই ইস্যু। আর বলো, আর কি কোয়েরি আছে বলো।
So the second question, sir.
সেকেন্ড কোয়েশ্চনটা কি ছিল?
Write an
timer.
assembly language. Sir, পুরাটা হচ্ছে sir, write an assembly language code that uses timer 1 in auto reload mode to generate a 20% duty cycle pulse train of frequency 2 kilohertz at P1.0.
So let's write the question first. ধরা যাক আমাকে একটা 2 কিলোহার্টজ ওয়েভফর্ম তৈরি করতে হবে। 2 কিলোহার্টজ পালস ট্রেন, 2 কিলোহার্টজ এর 20% ডিউটি সাইকেল পালস ট্রেন, ডিউটি সাইকেল পালস ট্রেন। ঠিক আছে, তাহলে এখানে আইডিয়া কি? 2 কিলোহার্টজ মানে কতটা টাইম পিরিয়ড?
0.5
কিলোহার্টজ মানে
0.5
মানে 500 মাইক্রোসেকেন্ড।
500 millisecond. Microsecond.
1 কিলোহার্টজ মানে 1 মিলিসেকেন্ড, তাই 2 কিলোহার্টজ মানে
Yes,
হাফ অফ দ্যাট,
yes.
মানে 500 মাইক্রোসেকেন্ড। ঠিক আছে, তাহলে 500 মাইক্রোসেকেন্ডে 20% 1 থাকবে আর বাকি 80% অফ থাকবে। তাহলে 1/5 পিরিয়ড 1 থাকবে, তাহলে
100
T1 কত হবে? T1 হবে 100 মাইক্রোসেকেন্ড।
100।
ঠিক আছে, মাইক্রো, আর টি অফ হবে 400 মাইক্রো। ঠিক আছে, তাহলে এই অ্যালগরিদমটা কি করে লিখবে? লেখার কায়দাটা আমি বলে দিচ্ছি, বাট ইউ প্লিজ write it on your own. So you generate a clock, generate a timer which will overflow after every 100 microsecond. Clear? and you keep a counter, simply a register, which will count from 1 to 5. So after every interrupt or after every overflow of the timer, you increment the counter by 1. If the count value is 1, you make P1.01. But if the count value is from 2 to 5, you make P1.0 equal to 0. So P1.0 will be set equal to 1 for 100 microsecond and set equal to 0 for 400 microsecond. এইটা হচ্ছে মেইন প্রবলেম, যে তোমরা কিন্তু যে কোনো ক্লাসে পড়িয়ে দেওয়া হয় সেগুলো দেখে আসো না। ক্লাসে না এলে ঠিক আছে, ওকে, I don't really mind it. কিন্তু ধরা যাক, so if I go to this, so I think timers is in part 3. Assembly language program. তুমি দেখো এখানেও কিন্তু এগুলো বলা আছে কিছু কিছু, টিপিক্যাল কি করে টাইম ক্যালকুলেট করতে হয় ইত্যাদি প্রভৃতি। এনিওয়ে, so if you go to timer 1.4, you'll find that at the end of this particular slide, end of this PPT, I've given you exercises. So that's it. Generate a 25% duty cycle pulse train of period 100 microsecond at P1.0. So this entire algorithm is there. So what I have to do is to follow this algorithm and write the code. So it's a 25% duty cycle. It means that on for 1/4 period and off for 3/4 period. So I've calculated on period is 25 microsecond and off period is 75 microsecond. Okay. So timer is initialized like that, is to the power 8 minus 25. So then it will overflow after every 25. Then you initialize R0 to 0 and increment it from 1 to 4 and then wrap back to 1 every time the timer overflows. So if R0 equal to 0, set P1.0. When R0 equal to 2 or 3 or 4, you clear P1.0. Clear?
স্যার এটার কোডটা একবার লিখে দিন স্যার, মানে
স্যার বলছি এটা ডিজেএনজি দিয়ে করা যাবে? লাইক আমি করেছিলাম একটা ভেরিয়েবলে 4 স্টোর করে, যেহেতু ওখানে আমাদের 5টা পিরিয়ডে ডিভাইড করা ছিল, টোটাল 4টা, মানে 4/5 পিরিয়ডের জন্য অফ আর 1/5 এর জন্য অন। তো ডিজেএনজি দিয়ে 4বার রিপিট করেছিলাম অফের জন্য, দেন
ঠিক আছে,
বাইরেটায়
আমি
ওই
দেখার চেষ্টা করছি, এটা তুমি দেখো কি হয়। ঠিক আছে, আমি টাইমার ইন্টারাপ্ট দিয়ে করছি, তুমি কোডটা বুঝতে পারো কিনা জানি না, কারণ ইন্টারাপ্ট পড়েছো কিনা আমি জানি না। আচ্ছা, সরি, আমি এখানে লিখছি। এটা যেরকম আছে, this is the basic information, right? So এখানে আমি লিখছি ljump 0040 hex। তার মানে আমি ওই 0040 থেকে মেইন লুপটা লিখবো। কেন? টাইমার মানে ইন্টারাপ্টটা কিন্তু ওই 0040 হেক্সের আগে থাকে। ওকে, সো at that location I'll write the corresponding ISR. তাহলে org 0040 হেক্সে গিয়ে আমি কি করবো? ফার্স্ট সে সাপোজ I'll use timer 0. The timer 0 কে ওভারফ্লো করতে হবে after every 100 counts, যাতে 100 মাইক্রোসেকেন্ডের ডিলে তৈরি হয়। So first I have to configure the timer. So we move into tmod hash, hash koi gelo, hash 01 hex, 02 hex. So timer 0 is configured in auto reload mode. Okay, so you have to initialize the timer. So move into TL0, a data which is 256 minus 100. Okay, so that's 156. So simply write 156. Okay, or if you wish, you can convert it to the corresponding hex data. So 156 in hex is 9C hex. Okay, so you write 9C hex. Then you move this content of to TH0. So here TL0 is the timer which will run with the clock, and TH0 will contain the auto reload value, which in this case is 9CX. Whenever the timer overflows, this data will be loaded into TL0. Okay. So then what you do, you simply set TR0, the timer flag. But since you will run it with an interrupt, so before starting the timer, what you have to do, you have to set on the timer interrupt flag. Okay, so we have to move into the interrupt enable register, a data which is timer 0 is the second bit, no? 0 1 0 0 0 0 1. So it's 82 hex, hash 82 hex. So that enables timer 0, and also enables the global interrupt switch. So once again, if you don't read the corresponding part, you will not understand. So that's the main problem. You have to go through the timer and the timer interrupt section and then understand this. But that's how we write the code. Okay. So there's the main code. So it will run. And after set T0, you simply run a self loop, which is L0. Simply write sjump L0. That means after initializing the timer and starting it, all I have to do is to wait. Because whenever the timer overflows, it will jump to the corresponding ISR, interrupt service routine. Okay. Now let's find out where timer 0 interrupt will come. The first interrupt is at all 03 hex if I মনে আছে কাউ interrupt বোঝা থাকে? So let's check. Let's check. So interrupts will be in part 5, hopefully. Sorry. You see timer 0 interrupt is all 0B hex. So that's the jump address of timer 0 interrupt. Okay. So write the code over here as whenever the interrupt comes, the program will jump to org 000B hex. And here you simply write the corresponding logic. What is the logic? The logic is you put into a register a value which will vary from 0 to 5. Okay. So that means over here you write move data R0 hash 00 hex. Okay. And the timer interrupt part, what you write is first you simply increment R0. Okay. So CJNE R0, comma. What is the corresponding CJNE instruction? So CJNE or data, hash data. Okay. CJNE R0 hash 01, comma, you jump to L1, L1. So if R0 is not equal to 1, you will jump to L1. But if it's equal to 1, you will simply write set P 1.0. And at L1, so if it's not equal to 1, two, three, four, 5. You clear P 1.0. So if R0 is 1, you set P 1.0, else you clear 1.0. Okay. After increment first it will 1, after the second it will 2, it will come here over here. Correct. And after that you simply write CJNE R0, once again as a statement. So if that is equal to, so for 1 it will be a 1, for 0, for 2, 3, 4 and 5 it will be a 0. Because there will be 5 sections, each of which 20%. The first 20%, the output will be a 1. For the rest 4, it will be 0. But when the count becomes 6, not equal to 06 hex. Hex. It goes to length. If it's equal to 6, what do? You simply reset R0 to 00 hex. Zero 06 hex ln, move R0 to 00 hex. Okay. So that's end of the program. So I require to put another jump address which is ln, where I do nothing. I simply write a nom followed by a ret I. End of instruction. So let's copy this and then let's check how it works or whether it works at all. increment R0. Let's first save it and check whether it's syntactically okay or not. So there is a syntax error at 21. So 21 is set. It cannot be set. It has to be set B. Okay. Let's save it. Right. So once again, I'm trying to accept the logic. The logic says that you generate a timer which will be interrupted after every 100 microseconds. So how do you do it? In the first line, you jump to 40 hex. So this is the main code. It sets R0 to 00 hex. So that's the counter. Because I have to generate generate time intervals of 100 microsecond for 5 instances. Then the total period will be 500 microsecond, which is equal to 2 kilohertz. So this counter is for that. R0 is a counter for that. Then I set timer 0 in auto reload mode. I set TL0 equal to 9 hex. I copy the same thing into TH0. So this is the running counter, and this is the register where I keep the auto reload value. Then I enable timer to interrupt. So that is what I write into IE. And then I start the timer. So after starting the timer, I simply wait for the first overflow. So whenever it overflows, it jumps to the corresponding interrupt. So the interrupt subroutine, what it does is it increments R0. So after the first increment, R0 will become a 1. Okay. It checks whether R0 is equal to 1. If it's not equal to 1, it will make a jump to L1. But the first instant, R0 will be a 1. So it will set P1.0 and will jump to L end of the program of this subroutine. And retime means it will once again come back to the main loop. Coming back to the main loop means it will wait in this loop because the timer is running automatically in auto reload mode. So the next interrupt, it will once again come back to this. Now increment R0 means R0 will now become a 2. So if you check this R0, it's a 2. So it's not equal to, R0 is not equal to 1. So it make a jump to L1. So it jumps to L1 means P1.0 is cleared. That means now the clock will be cleared. Okay. Now, next interrupt. Okay. After clearing the clock, what it will do, it will check whether R0 is equal to 6. If it's not equal to 6, it will go to L8. It will do nothing. So for the next 4 iterations, that means for R0 equal to 2, 3, 4, and 5, this is the running loop. But after 5, when it comes here, right, it increments. Don't make it 6, you make it 5, I think. Because up to 5, this will run. And when it's 5, we have to reset it to 0. 1. Okay. So that's how it works. So let's check. Let's debug. Okay. Let's do one additional change in the options part. In the output part, I put in the debug information. So that often helps if something goes wrong with the code. Recompile it and now go to the debug mode. Okay. So directly come to this line. So this means you run to the cursor. So you run to the cursor. So cursor remains 1 for this period. Let's zoom it in. Okay. Right. It remains a 1. So it comes over here. And then what happens? Now if you step, you see R0 is initially 1. Now it increments to a 1. Okay. So it's equal to 1. So port pin is being complemented, remains a 1. It jumps to ln. So that's end of the story. Okay. ln means it will go to the loop once again. So once again, you come to this increment R0. So that's the next interrupt. You run to cursor, come over here. So what happens if you step? It's increment, now R0 is 2. So 2 means it's not equal to 1. So it will jump to L1. It will clear this, right? And then after clearing, it will go over here and then it's retire. In the third instant, what will happen? Once you can come over here, you run to the cursor. So now if you increment, it becomes 3. 3 means, once again, keep this one cleared. It's not equal to 5. It will jump to ln and then retire. Okay. You go to, once again, you go to here. So now R0 is 4. Then R0 is 5. Okay. So then what happened? Now R0 is 4, R0 is now 5. Right? So when it's 5, it's being set cleared to a 0. Cleared to a 0 means on the next instant, it will once again become a 1. So if you repeat this, you will find that this is what really happening. It's remaining high for a period. You can measure this period. So this period is, say, this is 617 and this is 716. So 617 to 716 means roughly 500 microsecond. So this is 716 and this will be another 400 microsecond. This is 1.117. Okay. So 0.7 plus 4 is 1.11 second. So it's remaining high for 100 microsecond and it's remaining low for 400 microsecond. So that's the logic. So once again, I tell you, if you don't practice it and come to the exam, you can't do it. Most probably you can't do it, right? And the unfortunate part of it is that in every slide, in every section, I've given you examples. So unless you go through the examples, you cannot handle these programs properly. That's what I say. So now if you simply run it, right, you will find, so that is how the PWM signal is being generated. It's a 20% 2 kilohertz waveform. Stop it and reset it.
Sir, how to do it without using the interrupt?
হ্যাঁ উদ্ভাস কি বলছো? How to do it without interrupt? That you find out. You write the corresponding code. Why should I write the code for you? I given you one option. You find out the other option. But please remember in the question paper, in the question itself, right? It might be explicitly mentioned that you do it with interrupt. Is it okay, Utpash? So in the second classes, you have interrupt, you have serial port, and you have interfacing. Okay, that means section 4, 5, and 6. You have to cover this. Okay. Section 4, section 5, and section 6. Okay.
Sir, can you
So have to
repeat?
cover
Can you
this.
repeat?
Hmm?
Sir, can you repeat serial port interrupts and?
I can't hear you. Speak loudly.
Interfacing.
Okay, okay.
So in the interfacing part, right, what I'll give you is basically programs where the interface circuit will be given and you have to write the corresponding programming code. So the problem is you do this using this, you do that using that, okay, and you have to write the corresponding program.
So in the end sense, what is the distribution of marks regarding theory and programming?
It will be a 40-60 if I'm not wrong. Either a 40-60 or a, I mean, 30 to 40 is theory and 60 to 70 is programming. But programming is always application programming. It's not that you write a code that multiplies a number with another number, so on and so forth. It's mainly on application. Okay. So maybe such programs will be of 10 or 15 marks. Write a program which will find out the integer average, so on and so forth. Right. The majority of the programs will be on timers, on interrupts, on serial port handling. Any further query?
Sir, are there any reliable sources to learn these kind of application-based programming?
You go through the Scott McKenzie book. So they have umpteen number of programs written for you. So they
Okay,
solved
sir.
many problems. Scott McKenzie book is with you. The soft copy is with you. The point is, you really don't have much of a time. You have only 2 days to learn, which is very difficult. And after it's on 21 and the semester on 29, so you have 8 days. So that too is a difficult proposition.
Sir,
Bala.
will there be step marking in the final exam or in the CT exam?
Yeah, but if it's wrong from the very first step, how do I give you marks?
Okay, sir.
So in a timer program, if from the very start that say this count value is wrong, you cannot do that mathematics that what should be the count value so that you get a clock of this. Then you get very poor marks.
Okay, sir. Got it. Thank you.
Sir, the Scott McKenzie book, the chapter of program design, the entire chapter is missing from the soft copy.
There are the entire. No, there's
So like,
nothing behind program design. See, this is basically application oriented programming, right? I'll never give a program where you have to crunch numbers. I'll never give a program which says that you have two by two matrix. So write a program which will multiply this by this. Okay. So
okay.
such programs
So,
will not.
so the interrupts and timer programs would get in the interrupts and timers chapter itself, right?
So the two programs that I've given in classes, the first one is very elementary, right?
Yes.
So it do not require algorithm, right?
No, sir.
You only require to understand the fact that when you add two numbers, the sum can be greater than 8-bit number. So that's it. Nothing else is required. So if you divide by 2, it means you have a 50% chance that your program will give you correct result. So if you divide by 2, even if your program is correct, I'll give you 50% marks. Clear.
Okay.
But if you write shift through carry, I'll give you full marks.
Okay.
Okay, so that's all about programming. But the rest is depends upon the rest of the program will depend upon the corresponding hardware that's being using. If it's a timer, you need to know how to configure the timer to generate a time, how to configure the timer to generate a clock, how to configure the same to generate a pulse train. If it's serial port, you should know how to send serial port data, how to receive serial port data. Okay,
Okay.
so these are the things we should know in programming. So in the other part, you will find there are programs on D2A and NFD converter. So you should know how to program a D2A to generate a waveform. You should know how to grab data flow through a nativity channel, all those things. So until unless you understand that, the basic hardware, right, it's difficult for you to write the application program. But most unfortunately, you refuse to come to class. So now it's your problem, not mine. Okay. So I think let's do one thing. Let's keep it. So after 21st, so if you need some help regarding interfacing, we can have another class. Okay. Because you cannot cover up everything in 2 days. Today is a Friday, no? So you have to study and clear your doubts in 2 days. That is very difficult. Anyway, if you require help, you can call me on Sunday. We can also have a session on Sunday. CR, any further query? Or should we end the class? জয়দীপ আসো না পালিয়ে গেছো? আচ্ছা, এনিওয়ে চলো। আচ্ছা, ঠিক আছে,
Thank you, sir.
থ্যাংক ইউ।